Thank you, Yuval. Appreciate it. My name is Andrew Wissing, and I'm the CEO and co-founder of Inductive Ventures. Here with me today is Jeff Wissing. He's the CFO and co-founder, and we're here to talk to you all a little bit about our magnetic braking technology. Next slide, please. Typical brakes dissipate energy via friction, which is also a form of heat. They don't recapture any of it, leading to high maintenance cost and wasted energy. What you see here is an aircraft landing on a runway. There are currently 3 aircraft that land every second, every day. And so that gives you kind of a little bit of insight about what the market looks like. These brakes are used in carbon and steel material to dissipate this energy, and these lead to high replacement costs. Next slide, please. What you see here, the aerospace brake market is worth about $1.9 billion annually. We've done a commercialization study here looking at different aircraft platforms throughout the country. We're located here in Atlanta, Georgia. Delta is one of our partners. They currently operate the A320 as one of their models. They have 208 of these aircraft in service, which equates to about 832 brakes that need to be replaced every year. At an average cost of about $120,000 per brake. Delta is currently spending about $100 million on year just replacing the brakes on these aircraft. You can see the other platforms here. It is a scalable technology that fits on lots of different aircraft. And so these parts are designed to wear out. And by using our magnetic braking systems, we're trying to revolutionize the braking industry by providing them with brake systems that do not wear out. Next slide, please. This is a bench scale demo of our technology. It just kind of gives you an overview of what we're capable of. What you see here is a titanium disc spinning at about 200 miles an hour. When we introduce our magnetic fields, we're able to stop that disc in about 1 second. And so our technology meets the current FAA and military requirements. We're weight neutral. We offer the most torque for the lightest amount of weight with our motor generator technology. We have a scalable design to meet multiple platforms. It can be retrofitted into existing aircraft envelopes like the A320, the F-18, or the U-2. And we also have the opportunity to offer electric taxi and takeoff assist capabilities to the aircraft. Next slide, please. We have patented both active and passive brake technologies. We're in development for the A320 aircraft. We're also working with U-2 program office here in Warner Robins, Georgia, on developing a magnetic braking system for the U-2. We also have a program of record with the NavAir and the Defense Logistics Agency for the F-18 aircraft platform. We have future programs planned for the CH-47, not only for the wheel brakes, but also for rotor brakes. We're also working on an Agility Prime Phase 1 SBIR, looking at this technology for use on drones. And then we've also been speaking with Hyperloop about using these braking systems on their vehicles. Since Hyperloop operates in a vacuum environment, a friction-based system that generates heat and sparks would be a really bad operating condition. And so they're looking for something that has no friction and no rubbing parts that operates magnetically. We're expanding our patent portfolio internationally, and that's something that we're working on right now. Next slide, please. We're looking for an injection of cash to grow the company, expedite testing, and develop new magnetic braking systems for new market applications. As I said here, Delta is a partner of ours. We're also working with Collins Aerospace. Collins Aerospace currently has about 2/3 of the braking market. They're a strategic partner of ours. We're also talking with Safran Landing Systems based out of Paris, France, who is interested in investing in the technology. We have worked with NavAir on the F-18, working with the U-2 program office on the U-2 brake. Lockheed Martin is also a partner of ours, along with AFWorks. We believe we invented the holy grail of braking systems, a brake that never wears out. Next slide, please. As for other market applications, any market that has a friction brake is a candidate for a magnetic brake. This includes automobiles, trains, helicopters, elevators, cranes, and other heavy industry applications. We decided to focus on the aerospace industry at first because this was the hardest application. We figured if we can make our brakes work in the aerospace industry where weight is super critical and the performance of the brakes is the highest order, that we could make this technology work anywhere. And so we believe it's scalable, like I said, and there are several other markets that we can expand on beyond the aerospace market. Next slide, please. Inductive Ventures was founded in 2017. We patented both the designs. The management team is Jeff and myself, and our goal is to disrupt the carbon brake industry by utilizing solid state magnetics to create safe and wheel brake systems that don't wear out. Next slide. A little bit of revenue, financial projections for the aerospace only. This is kind of where we think we're going. By 2023, we think we'll have an order for 32 brakes that are going to be put on the U-2 aircraft. By 2024, we'll have an order for the F-18 testing, and we're expect to grow the business from there on out based on other aircraft platforms that are come online. Currently, the state of the art is a carbon brake system that's been around since just after the Second World War, and nobody's ever done anything like this magnetic braking technology to revolutionize the industry. And so we think by using these new materials and new braking techniques that we can definitely change and provide the military and other commercial airline partners parts that are not designed to wear out. Thank you.
The magnetic brake system, it's been in use for several decades in the trains and things like that. So, what's the key tech difference here from your perspective in applying to the aircraft? And then, secondly, where is your source of tech differentiation? Like what from your background or from your team and whatnot? Like where is that differentiation coming from, especially in a technology that's been around for several decades, used in trains and things like that?
So we've developed a motor that's able to provide the most amount of torque for the least amount of weight. And we're also combining motor generator technology with braking technology. And so for the industry, like kind of like for trains or whatnot, they're basically just focusing on the braking. They're not able to provide taxiing capabilities to the vehicle. And so we're combining that motor generator / brake all in one concept to the aircraft, and we're fitting it into the existing space on board the vehicle at a weight neutral opportunity that fits into it, competes directly with the carbon brake.
If you help me understand your revenue projections, you call it royalty. So you sell your braking system to Delta. What do the payments look like over time?
So the way the current system works, when Collins or Safran sells their brakes to Delta, Delta currently doesn't pay anything to them. They pay for the brake by every time the plane lands. And so they're able to charge really, really high fees for these brakes that have maintenance and all this other stuff rolled into it. And so we were kind of looking at the same kind of plan that says, okay, we don't want to ask them to come out of pocket per se to pay for the brake, but same kind of model that says, we can finance this a way that we can, they can pay us per landing basis, and then we'll make a royalty based on that.
And how long does it take to recover your cost of producing that brake?
Really, really fast. So we did a business case analysis. We're looking at a project right now with the A-10 program office for the A-10 Warthog, and there's a payback period for the whole fleet of the A-10 fleet for less than 3 years. And that doesn't include logistics or associated personnel costs for actually doing the maintenance. That's just on the hardware alone.